Hello, everybody. Welcome to Code Vipassana Season 9, Session 3. This session will be all about building a toy store search app with cloud databases, serverless runtimes, and open source integrations. A little bit about what we're going to do in this lab. We'll create an AlloyDB instance and load a Toys dataset. We will enable the pgvector and generative AI model extensions like AlloyDB, generate embeddings from product description and perform real-time cosine similarity for user search text, invoke the newest model by Google Gemini 2.0 Flash to describe the image uploaded by user for contextual toy search, invoke Imagen 3 to create a toy based on user's interest. It will be custom. Invoke a price prediction tool created using GenAI Toolbox for databases for price details of the custom related toy. And lastly, we'll deploy the solution in a serverless Cloud Run function. Imagine stepping into a toy store virtually or in person and finding the perfect gift is effortless. Well, using this app, you can describe whatever you're looking for, or upload a picture, or draw it, or even design your own creation. And the store will instantly understand what you're looking for and will deliver that toy to you. When connected to an actual system, this will not just be a fantasy anymore, this will be a reality. To start off with, we will simply need a Chrome or a Firefox browser and a Google Cloud project with billing enabled. Let's start. Let's discuss the architecture for this app. The data flow. First, we will be using a contextual AI powered RAG system where if you're just looking for a red car, the system won't understand the red car as a red car, but maybe it will contextualize it and understand it as a small vehicle suitable for a 3-year-old boy. Then we will be using AlloyDB as a foundation. AlloyDB is Google's fully cloud managed Postgre compatible database. Then we will be using pgvector for semantic search. It is a Postgre SQL extension and it allows us to store vector embeddings. We will be using cosine similarity for relevance. This will be finding a relevant search between the user search and the toy description vectors that we have in our database. Then we'll be using the scan index, which is scalable nearest neighbors index. This will help us get accurate results since our toy inventory will be growing very fast. Moving on to the next part. For image-based search, we will be using Gemini 2.0 Flash. We will invoke this model using LangChain 4j to analyze the image and extract relevant content, such as the toy's color, material type, and intended age group. Then, to build the dream toy which was customized, we will be using Imagen 3. For price prediction, we'll be using GenAI toolboxes. We'll be using Java Spring Boot, Gemini Code Assist, and Cloud Run for streamlined development and serverless deployment. Before we begin, let's ensure we're in a Google Cloud console and we have a selected Google Cloud project. We have to enable billing and we have to make sure that we are using a Cloud Shell. I'll just show you how to do all of these. Let's go to another tab. This is how the Google Cloud console looks like. You simply have to go to console.cloud.google.com. Here you have to make sure you have a project ID selected. You can see if you are working in a directory, that means it's a project ID. Here all your projects will be listed. You can select any project. For my demo case, I will be using the project test-code-vipassana. The project ID is also test-code-vipassana, but please note that you will all have different project IDs and make sure to remember this project ID. You can always come back to your home screen of console.cloud.google.com and copy your project ID from here in case you forget it. Once you're done selecting your project and know your project ID, now we'll need to initialize the instance of Cloud Shell and the editor where we'll be working, editing our code, and doing a lot of things. So you see the icon here right beside the Gemini icon. We can click on that to activate the Cloud Shell terminal. From here, we can click on Open a New Window. Once we click on Open a New Window, it will ask us for any authorization. I have already given it, that's why it's not asking me. You can click on this tab to close the terminal and open the editor from this tab. You can see this looks like a very similar environment a lot of you would have worked in. This is a VS Code kind of environment built on an open source project. You can see we also have a terminal here and an entire editor here. This is the place we're going to be working on the most. Apart from the Google Cloud Console, you can close this terminal here and keep this page for all your other steps, for example, AlloyDB or anything else. Let's continue. Okay, these are the commands that we need to run to make sure that our project is set. And before we begin with the database step, let's go and run them one by one. Gcloud auth list, control, command C, command V, enter. It says active, that means my current terminal is connected to my Google account. You can see that's your email ID should be there. Then the next command we'll be following is gcloud config list project. This will show you if you are connected to a project inside of your terminal. If it says unset, you will have to select a project right now. You can see you'll always have this command at the top of your terminal, which is gcloud config set project and project ID. I will be deleting the project ID part and entering my own project ID. In my case, which was test-code-vipassana. In your case, it will be your unique project ID. You can see now the project ID is displayed here inside the terminal. That means it is successfully set. To check if this is successfully set, you can just run the previous command again and it will show you the name of the project ID. Here you go. Project is test-code-vipassana. Then we need to enable some APIs. We can do these by running these commands one by one in the terminal. But the way that I would prefer to do it and the way I would prefer for all of you to do it is copy the link given in the code lab just below the command of the APIs, this link. Go back to the terminal where your Google Cloud Console is, paste it in the browser, press enter. Make sure that you are in the same project, click on next. It will enable all the APIs for you one by one and you will not need to do a thing. This is a very robust process which will make sure that there is no fault, and once the button is grayed out, you will be able to see that all the APIs have been enabled. Let's continue. We are done with the before you begin step. Now we'll be moving on to the database setup and we'll be using AlloyDB as the primary database to hold the toy store data. It uses a clustering mechanism such as database and logs, and each cluster has a primary instance that provides an access point to the data. Let's start with this and let's see what steps we need to follow. We need to navigate to the AlloyDB page in the Cloud Console and create a cluster. I'll show you how to navigate. Remember the tab we left open, the Google Cloud Console page. Come there, click on AlloyDB, this first option. Okay, you can see that right now I have none. What we can do is we can click on create cluster. The API was already enabled, so it will be very quick. What do we need to do next? We see this exact screen in front of us as you can see here. So we need to follow the steps that are given here. We have to give the cluster ID as vector cluster. We have to give the password as AlloyDB. Database version PostgreSQL 15 compatible is good enough. The region has to be US Central 1 and networking has to be default. Right. Region has to be US Central 1. Networking has to be default. Since we see this exact screen, what we will need to do is we will need to click on setup connection and use the option use an automatically allocated IP range and click on continue and create a connection. So we click on setup connection, we click on use an automatically allocated IP range, click on continue and create the connection. Once the connection is created, we'll be able to continue with creating our cluster for AlloyDB, which will handle all our data for this project. This might take some time depending upon your project, your internet speeds, and a lot of other factors. Don't worry, let it process, let it do its thing, and it will be done. As you can see, the private services access connection for the network default has been successfully created. Now, we can configure our primary instance. Let's go back to the code lab and check what we have to do. Here, what we need to do is we need to set our instance ID as shopping-cluster-primary, select multiple zones, 8 virtual CPUs and 64 GB of RAM, and create the cluster. You can leave the instance ID to whatever you want it to be, but then make sure to remember your instance ID since we will be using this in a lot of different places. Here we are changing the instance ID to vector hyphen instance using multiple zones, 8 virtual CPUs, 64 gigabytes of RAM, good enough for connectivity. That's all we need to do, private IP connectivity, and we're good to go. We can click on create cluster. You can see it has started running the process. It will take some time, create the cluster, and then we can continue with the code lab. Now, the next step is to ingest the data, for which we will need to go to AlloyDB and navigate to the AlloyDB Studio. But before we can do that, before we can go to AlloyDB Studio, you need to make sure that the creating instance is done. Even though it shows ready here, it is not currently done and it will take some time. So wait for a little bit, make sure that your AlloyDB instance is created. I will fast forward this part to the part where our cluster is ready, and then we can move on to the AlloyDB Studio. As you can see, our instance is finally created. It took about 7 to 10 minutes to create the instance, but once it's ready, we can go to the AlloyDB Studio, select our database Postgres, select the user, the password, remember our password. Okay, we have to log in with the password AlloyDB. That's what we're going to do. Authenticate. You can see we're inside the Explorer. These are all the things that you will be seeing. What we need to do is we need to go into the editor. You can open multiple editors. This is what will allow you to run SQL commands inside of AlloyDB. Let's go see what we need to do. For building this app, we will need to use certain extensions. So we can simply enable them or create them using the SQL commands itself. So let's run them one by one. You can see I get a run option. I just click on run. Statement executed successfully. We can go to the next one too. Since SQL is sequential, you could have just copied both of them, pasted both of them together, and click on run, and it would have still executed the statement sequentially and successfully. If you want to check the names of the extensions that are available, we can run this command, and you can see we have all the extensions available, including the ones that we just wanted. We're good to go. Now, let's create a table. We'll be using a simple SQL query to run, create a table called Toys. This will be having multiple fields like ID, name, description, quantity, image URL, etc. etc. Let's click on run. You can see the table is created. You can also check it here. We have a table called Toys, but currently it is empty. So we need to ingest the data from a SQL file. What we can do is we can click on this link to lead us to a hyperlink SQL file, and we can insert the first 5 records of this file into our table. Why we're doing only the first 5 records? Because we are on a trial billing account and these things cost credits. So we don't want to use up all our credits in just ingesting the data. That's why for now we are only ingesting 5 records. Once you have copied these 5 lines, go back to your editor, paste it there, click on run. You can see statement executed successfully. Let's go back to the code lab. To see the table contents, we will be expanding the table. Let's say we expand the table. We can see we have 7 columns: ID, name, description, quantity, price, image URL, text embeddings. We have all the things that we need. If you want to just view everything that you have imported into the AlloyDB username, we can select star from toys 1. Click on run. You can see because I put limit 1, it has only showed us the first ID, the first row of the column, since we have 5 records, and if I would have put limit 3, it would have showed us the 3 records that we have. So that is cool. Now, we need to grant permission to execute writes on the embedding function for the user Postgres. For that, we will need to execute this into the editor. Let's run this. Run. Statement executed successfully. And finally, we'll have to give the Vertex AI user a role in the AlloyDB service account. So this we'll have to do in the terminal. So remember where our terminal was. Right here, I click on paste. Project ID is already set. And then we go and copy this entire thing, paste it, press enter. You will see it has assigned the roles to us and successfully done. Let's click on next. Now, we need to create embeddings for context because for computers it is much more easier to process numbers than to process text. And that is exactly what embeddings does. They convert a series of text into a floating point numbers that represent the text no matter how it's worded or what language it's used. Let's return to the AlloyDB studio and type the following DML. DML stands for Data Manipulation Language. Let's return to our AlloyDB instance and run the command. You can see statement is running. This is generating the embeddings. Statement executed successfully. Now we can have a look at all of these records that we have just modified, and you can see the floating numbers that we spoke about. It has generated them and we can have a look at it. Now, finally, this is how our result should look like, and this is exactly how it looks like. So we're good to go. The next step is to perform vector search. What we can do is let's say I want to ask the app, I want a white plush teddy bear with a floral pattern. The way we can do this in AlloyDB is we can give the query by performing this SQL command where we're selecting star from toys, which means we're selecting the entire row from the toys, but we're ordering it by text embeddings where we're casting on it the text embedding model and the query that we want. Limit to, we'll click on run, and you can see it comes back with two images of the descriptions of the images of the text embeddings, so it works. We can use this step to improve our efficiency and recall with scan index, but we only have to do this if our record count is greater than 100. Since we're only working with 5 records right now, we don't need to do this. So we're okay, we're good to go. Next, we need to match the validation with the LLM. We need to ensure that it is set up for Gemini. Let's check if Gemini is enabled. We'll go to another tab, paste that command, click on run. It says on, so our Gemini is good to go. Since ours is on, we can skip the next two steps. These steps are primarily showing us how to enable the Google ML integration instance. You can follow the steps if needed. For us, we don't need to. Okay, now we need to connect our AlloyDB and Vertex AI model together. We will copy this command, paste it in our AlloyDB in another editor, press enter. We will replace $project underscore ID with our project ID. In my case, it is test-code-vipassana, and we will click on run. You can see statement executed successfully. That means we're good to go. We can select the configuration by running this command. You can see text embedding, Gemini 1.5 Pro, Gemini 1, Gemini 1.5, all of it is here, so we're good. Finally, we need to grant the permission for database users to execute this function to run predictions. We will copy this DML command, we will paste it here and click on run. Statement executed successfully. Now, we'll need to evaluate the responses. This is a very large query that we're going to run. The explanation is here, and for the sake of this recording, I will not be explaining you what this looks like. It is pretty self-explanatory, and when you actually break down the command, it is pretty simple to understand. So don't worry if it looks daunting at first. Trust us, it is very simple. Once you run the query in AlloyDB, it will show you the contents of a row, and Gemini will have validated it saying match yes. We're good to go. Now that our app is almost ready, we can take the toy search to the cloud serverlessly. How we can do this is we can copy this link here, paste it in the place where we have all our projects enabled, and we can add a new cloud function. Let's see how to do this. We will select the environment as cloud run function and provide the function name as get toys AlloyDB. Let's do that much first. So we will be using an inline editor to create the function. Let's click the service name as get toys AlloyDB. The region will be left as US Central 1 Iowa. Then we have to select authentication to allow unauthenticated invocations and click on next. Choose Java 17 as the runtime and inline editor for the source code. We've already selected the inline editor for the source code. For the runtime, we'll be selecting Java 17, and we have to allow unauthenticated invocations. Okay, the third step is what we'll come back to. We'll keep the files open. This is the hello http function.java. This is the pom.xml. We'll come back to these steps. Since the Google Cloud Console has been changed a little bit, it will be a little difficult to find these steps, so make sure you follow along. Then we need to create a connector and route all the traffic through this connector. So what we'll be doing is we will scroll down. It will look like this. So we need to expand this section, come to the networking section, enable the checkbox that says connect to a VPC for outbound traffic. Click on use serverless VPC access connectors. We don't have one, so we will click on add new VPC connector. If it asks you to enable an API, you can enable one API. You can provide any name, let's say AlloyDB connection. The region has to be the same region that we have selected throughout this project, which will be US Central 1. The networking has to be default, and the subnet can be anything. Let's say it can be any IP range. What in the code lab we have given it with the range 10.8.0.0. So we'll be selecting that and pressing. We need to show the scaling settings. We will need a minimum of 2 instances, but a maximum of 3. And the instance type has to be F1 micro. Let's click on create. You can see that it is taking some time to create the VPC access connector. We cannot click on create until and unless this connector is created. So let's wait for this connector to be created. Until then, you can select the setting, route all traffic to the VPC, go to containers, and we can change some more things. If you must have seen, we have to increase the timeout to 180 settings. So let's go and do that. We can go to request timeout, and this will be any value for you. We will keep it as 180. Volumes. We let the VPC connector get created. It says successfully created the connector. Now we're ready to click on create, and we'll create the service in Cloud Run. As you can see, the function entry point is this code. What we'll need to do is we'll need to change this code to the code that we had in the GitHub. So you can see this is our hello http function.java. We can simply copy this code, paste it here, and we have our entire endpoint code ready. Very important thing to do is replace our project ID. So what do we need to replace? Let's check in the code lab. We need to replace the instance your project ID with our actual project ID. So you can see that there's only one instance of your project ID. I will replace it with my project ID, which is test-code-vipassana. You can replace it with your own project ID. Click on this button, it will get replaced. You're good to go. We will save this. We will go to the pom.xml file. Again, replace the code from the GitHub repo. We can copy this code, paste it here. Again, replace the project ID with our project ID. This does not have any project ID instance. Still, let's just skim through the file and see if we need to replace anything. There's nothing that we need to replace, so we can save and redeploy. You can see it started working, complete, and it has redeployed the function. Let's go back to the code lab. Now, we need to test the Cloud Run function. We can see that there is a URL for our Cloud Run function. The build is still happening. It is not yet successful. So we'll wait for all of this to be ready and there with a tick mark, and then we can go and test our Cloud Run. Okay, so now that we're done building the application, we can test it in Cloud Run. For that, what we need to do is we need to copy this command and paste it in our Cloud Shell terminal. I'll copy it, paste it in our Cloud Shell terminal. Make sure you have the project ID set. Make sure you have the project ID set. If you don't, just use the command again, gcloud config set project and set your project ID. One very important thing to note here is you need to change your URL after post. So what you need to do is you need to go back all the way to this URL where it says AlloyDB, delete the entire thing, open your Cloud Run function, which is open in your console.google.cloud.com. Mine has gotten closed, so I'll just go and open it again. Cloud Run. You can see this was our get toys. This is the URL I want. I will paste this in Cloud Shell, and now I will press enter. It will take some time, approximately 180 seconds, and get back to us with the result. Until then, we can move forward. We will build the web application client. For this, we will need an API key of Gemini. We can copy this link of AI Studio, go to Gemini, press enter. You can see I already have some API keys, but for this test, I will create it again. Let's say Gemini, this is the project that I was using, create an API. It will generate an API key, and let's copy this and store it somewhere. Once you've stored it somewhere, we go back to the code lab. We need to clone a repository by using this command. So we will use this command, copy this repository in a new terminal. You can see the project ID is not set here, so I will use the gcloud config set project test code Vipassana. We can clone the repository. I already have this repository, but for the sake of this code lab, you can see it's right here. What you need to do is you need to go and open folder. This is where you'll be left to. You can click on toy search and click on OK. This is how your Explorer will look now. If you don't see a terminal after this step, click on terminal and click on new terminal. Again, your project ID will be unset. So use the project ID setting command, which is this, and set your project ID. Once you're done with this, we need to follow the commands of the code lab. Let's go. Let's enter into this directory, cd toy search, and then we will need to do some things. There are some folders here that are get toys AlloyDB and toolbox toys that we need to delete. We will be deleting these folders from here. Delete, delete. Then we have to do one very important thing. We have to delete one line from a file. You have to go under src main java web, the file called generate-toy.java, and scroll to line number 60. You can see that there is a line called %generation allow adult. You will select this line, remove it, press Command S or Control S and close it. And now we're ready to move ahead. Let's select this command, press enter. This will set our project ID as the current project ID. Then we'll export this project ID in our terminal. If you make sure you have an equal to between these two, if you don't, just include one. We will now enter our Google API key that we previously stored. If you didn't store it anywhere, go back to that space, click the Google API key, copy and paste, press enter. All your exports are done. Now what we can do is we can click and build this application. Ambient package will help us build this application locally for Java. You can see it has started building, compiling, running unit tests, and running Spring Boot. Soon it should be done. Let's copy the next command, which is ambient Spring Boot run. Enter. It is scanning for the projects and it will be done in a sec. You can see our application is now running. So I will click on web preview, preview on port 8080. And this is how the application looks like. You can search for anything or create your own toy. Let's say I want to create a remote car with a teddy bear on it. I will click on create your toy. It will take a second, 10 seconds and give us a result. After this, we move to the next step. This step is all about understanding the generative AI details. So you can go through the code, go through the steps, and you can check things out at your own time. Same goes for this. GenAI Toolboxes for data sources. Databases is an open source server by Google that makes much easier to build applications like these and interact with database. You can also check this out on your own. And this was the last step. We can test our web application. You can also look at this YouTube short that shows us how to test out our web application. We can clean up this application. What we need to do is we need to go to the manage resources page. I will copy this link, go to our pages, manage resources. I will select my project, click on delete. And I will enter the project ID and delete this project ID. Once you click on delete, click on shutdown and your project ID will be deleted. Before deleting the project ID, make sure you get the screenshot which is required and also you get a success message from the code lab. Thank you.